All right, this morning we're going to continue indexing basics. This is part 2, and this slide will be also for part 3 as well, maybe even for part 4. So first we're going to look at the left-hand side of the screen currently, and we're going to talk about the logic of what's happening behind the scenes. Because I think if people don't quite understand the logic of what's happening behind the scenes, it is a little confusing, and it probably makes less sense what we're doing on some of the indexing structure. So let's go back to the example in the previous video where we were talking about the book of Jonah. If you think about it, if we're given a 1,000-page book and we're saying, go find the book of Jonah, a very logical thing to do would be to go to the table of contents and figure out why. And why do you think that is? Because it's not efficient to search through the whole book, right, to find one little book in the Bible, right? Like, that's not an efficient search to do. So let's use the left-hand side of the screen here. And, or let's look at the left-hand side, and you'll see that there's a box with S, and you'll see that there are 6 blocks, right? Now, suppose that we want to look at block 5, right? Okay, now in this simplified example, would it make sense to search every block until we find block 5? So starting with 1, 2, 3, 4. Okay, I mean, that would be very costly. We'd have to do basically the equivalent of 5 reads, right? But imagine if I told you that in this S block, I had a way that we could look at the S block and we would immediately know which block to look at next, right? So this S block would be linked to all of these other blocks, right? So in other words, by hitting that S block, I can immediately figure out which 5. How many reads is that? I have to read the S block, and then I read the 5th block, right? Whereas in the other route, if there's no S block, I have to read 1, then 2, then 3, then 4, then 5. That's 5 reads versus 2, right? So remember that as well when you're doing your statistics IO, when you're getting the logical physical reads, right? What is happening behind the scenes, right? Because the goal is to reduce that, okay? So let's go back to SQL Server for a second, and let me pick on myself. This is the statistics property here of a savings table, right? And this has savings dates. So here's a question that you can pause this short video and think of how you would answer this. What would be a way of organizing these data? So let's look at these data for a second. We're looking at date ranges, right? You'll notice that here that in this example we have range rows for 1959, 04, 01, we have 6. For 1959, 08, 01, we have 9 rows. For 1959, 12, 01, we have 9. You see these ranges here? Well, think about, again, what happens if I pass in, let's say, 1967, 04, 01. What assumptions do you think I can make with these ranges versus, let's suppose that, I'm not exactly sure, let's just say there were like 700 records in this table and there was just one range, right? What assumptions would have to be made? So this is a very simplified example of what the value of indexing when we think about an index. And again, this goes back to, we don't want to just build any index. We want to build an index based on those assumptions. Like, for instance, building a clustered index on a text field. Well, it depends on the text field, right? What are the searches that are going to be used? I want to know ahead of time, as much as I can, what type of searches are going to be used on a table, so I can think about the way that I want to index a table. Now, in the next video, we're going to use this slide. We're going to be going over to the right side of the screen, and we're going to then look at how SQL Server breaks that down, and then, of course, some information that we can dig into to get information about these indexes.